Okay, so we're going to work on lesson 4.6 now. And with lesson 4.6 is called the fundamental theorem of algebra. And we are basically going to be working with factors and whether factors are zeros or not. And then when we find the factors, we're going to talk about how can we write those, or if we find the zeros, how can we write it in factored form. And so that's what we're going to do right now. We're going to work on just some of the basics of that. And then we'll do a couple of examples that for you. So first of all, some of the things we want to be reminded of is how do I know if something is a factor or not? And I know something's a factor is if I plug in the 0 for that factor, if it gets 0 for it. So for instance, all factors are written in the form of x minus c. So we want to know is if I put c in for x, will I get 0? If I get a 0, then we know it's a factor. If I don't get 0, then it's not. So here we have an example A here, that x to the 15th plus 3x to the 7th minus 5 is our function, right? And I forgot f of x. So f of x equals that. And they want to know whether x plus 1 is a factor. So what I'll do is I'll just put in -1 for x and simplify it. If I get 0, then it's a factor. If I don't get 0, then it's not. So let's see. We get -1 when I do -1 to the 15th. -1 to the 7th is also -1 times 3 is -3. And when I subtract 5, I get -9. Since this does not equal 0, then x plus 1 is not a factor. And that's how we can do it by not using synthetic or long division. We can just find the 0, plug it in. If it works, if it equals 0, then it's a factor. If it doesn't, then it's not. Okay. Here we want to list the zeros of the polynomial and state the multiplicity of it. So our zeros here, so our function here, f of x, oops, I got red, I don't want red. So multiplicity is just basically what is the degree of the factor. So here my zeros are -3, 7, and -e. Okay? It doesn't have to be a rational number. It can be an irrational number. So the multiplicity then is just the degree of each factor. So 5, 3, and 2. Easy as that. Okay, then we're going to look at examples 1 and 2, similar to examples 1 and 2 in your book. That'll follow along with helping you to with this lesson. So one of the things is, if I know the zeros, can I find a polynomial that will give me those zeros? And so this says find a polynomial of degree 5 such that 1, -2, and 5 are the zeros. It says 1 is a 0 of multiplicity 3, and f of 2 equals -24. In other words, if I put +2 in for x once I'm done, I want to get -24. So our main function we're going to be using is this one here that says f of x equals k times x minus a times the quantity x minus b times the quantity x minus c. Since I have 3 zeros, I'm going to have 3 factors. Now, k, the reason I have k there is because with k, we need to be able to find the scale factor or growth or compression so that when I put in 2 for x, I'll get -24. And so this is what we do for that problem. First, I'm going to go ahead and plug in my zeros. So I have x minus 1, x plus 2, and x minus 5. But it says that 1, the 0 at 1 has multiplicity of 3, which we know then that means that this factor is cubed. So when we're doing this, because the degree is so large, a fifth degree polynomial, we're not actually going to multiply this out. You could figure that out, but we're going to go ahead and leave it in factored form. Well, they do want us to find the polynomial, so we're going to find it. So the real thing. So now we're going to, before we go on and do all the multiplying, we're going to find our value of k. And to find the value of k, we're going to put in negative 24 for f of x, and we're going to put 2 in here for x. So when I solve this then, we get negative 24 equals k times, let's see, this is 1 cubed is 1, times 4 times negative 3. So our value of k, so negative 24 is equal to negative 12k. So when I divide, we get k equals 2. So my polynomial then is going to be f of x equals 2 times x minus 1 cubed times x plus 2 times the quantity x minus 5. And then we'll go ahead and we'll multiply that out. All right? I'm not going to do it for you right now, but that's something that you can do. I would do, in my multiplication, I would multiply these first, multiply the factors first. So I would multiply these two first, find this cube, and then I would just double all of my coefficients from there then. All right, so let's look at another one. Here we have a 0 at negative 3 and I, and f of negative 2 equals negative 15. So for this one, because I have a 0 at I also have a 0 at negative I, because of the rule for complex conjugates. Which that rule states that if you have a complex number, or a 0 that's a complex number like a plus bi, then you would also have a 0 at a minus bi, where the complex number is the opposite. So since I have I is a 0, then negative I is a 0 also. Okay. Now when I write them in factored form, I'm going to use this general form again. X plus 3, x minus I, x plus I. And it says that f of negative 2 equals negative 15. So let's go ahead and work with that then. So we can find k. So negative 15 equals negative 2 plus 3 times negative 2 minus I times negative 2 plus I. Now with this one then, we're going to have to multiply negative 2 minus I and negative 2 plus I. We're going to have to do that multiplication. So we get negative 2 times negative 2 is 4. So we actually have to do some foiling here. Now the nice thing about this is we have difference of two squares. Because when I multiply these together, I get a negative 2i and I get a positive 2i. When I add them, I get 0. So then I'm just left here with negative I squared. And if you remember from our earlier study with complex numbers and with I, that I squared is equal to negative 1. So this is the opposite of negative 1. So 1. So we've got negative 15 equals k times 1 times 4 plus 1 is 5. So we divide by 5, and k equals negative 3. So our answer here then would be f of x equals negative 3 times x plus 3 times x minus I times x plus I. And when I actually multiply this out then, okay, this part here is the difference of two squares again. So this part is just going to be x squared plus 1. All right? For the same reason we had up here. So you have x squared when I multiply x times x. The middle term is going to cancel because it's difference of two squares. And then I times I is I squared, so that we have negative I squared, which once again is equal to positive 1. So this would be x squared plus 1. So then you just have to finish that multiplication to find the actual function itself. Okay. All right, so let's look at one more. And we're going to talk about conjugate zeros. And with conjugate zeros, and then we're also going to talk about writing them as linear factors. So we're going to take these and we're going to factor them. And we're going to factor them by finding the zeros to be able to do that. So first of all, we'll go ahead and do letter A here. This first one I've got from example 2, x squared minus 6x plus 13. Now, since this is not factorable, okay, there are no factors of 13 that add up to 6, then I'm going to have to either use completing the square or the quadratic formula. So I'm going to go ahead and use the quadratic formula here to do this, to find the zeros. So we get x squared minus 6x plus 13, so we have minus x equals negative b over 2a plus or minus square root of b squared minus 4 times a times c over 2a. So we get 3 plus or minus, let's see, in the numerator, I get 36 minus 4 times 13, which is 52. So we have negative 16 here over 2. All right, 36 minus 52 is negative 16. So the square root of 16 is 4. So because it's negative 16, that part's going to be 4i. So we get 3 plus or minus 4i over 2. So my zeros are 3 plus or minus 2i. Now, to be able to write that in factored form then, all right, so we want to actually factor it then. Then we would say that f of x equals x minus 3 minus 2i and x minus 3 plus 2i. Because remember that your factors are always x minus a and x minus b. So I'm going to be doing the opposites then. Because of the minus, it would be the opposite. So the opposite of 3 plus 2i is negative 3 minus 2i. The opposite of 3 minus 2i is negative 3 plus 2i. And so there we have the factors. And I'm going to go ahead and do one more. I'm going to do this one that I've identified as 2a. And then you can do 2b on your own then if you want to. Okay, so here we have a fourth degree polynomial, but there are only 3 terms. So I'm actually going to factor this just like if it said x squared plus 3x minus 54. The only difference is that my first terms in each of my factors are going to be squared instead of just being x. Because it always works out that whatever this middle term is, that's what goes here and here, as long as the degree of the first term is twice the degree of the middle term. So when I factor this, the factors of 54 that add up to 3 are 9 and 6. So this would be a positive 9 and a negative 6. So I set those individually equal to 0, and we would get x squared plus 9 equals 0, and x squared minus 6 equals 0. So x squared equals negative 9, x squared equals 6. So my answers here are going to be x equals plus or minus 3i. So we're going to take the square root of both sides. And the square root of a negative number is a complex number, I. Square root of 9 then is 3. And here then we get plus or minus square root of 6. So if I want to write this in factored form then, I would do it just like any other ones we do with our factors. Write them as the opposite. So we get x minus 3i, x plus 3i, x minus square root of 6, and x plus square root of 6. Okay. So here are the zeros, and here I've written it as the product of linear factors. And so that would be the main part that you get you through section 1 for your pre-calc assignment. Now, if you're going to do letter B here, you have to factor this one also. And the factoring cubic, the sum of two cubes, that's actually on the first page. If you open up your book, take the front cover, open it up, you'll be able to see the factoring for that there also.